Okay, today we are on page 3 of the Chapter 5 notes packet. We are going to finish up section 5.2. In our previous lesson, we learned how to, like this was the top of the page, we learned how to take our probability distribution and calculate the mean, the variance, and the standard deviation for them. Now, we're going to work with the same concepts today. We're just applying them to a different type of word problem, okay? And one of the big deals is first we need to talk about mathematical expectation. Okay, on your formula card, we already had the mean equals this formula. But we really also have this capital E of X. This is E, this is the sum, sigma. E of X is your mathematical expectation. We can also call it your expected value, your expected gain, or your expectation. It's what we're expecting to happen on average. So it can really be called any of those types of things, all right? It can be called any of those terms, and they all represent the same concept that we want to look for in a problem. So a lot of times this idea is used in raffles, or lotteries or any of those kinds of things. We're going to talk about some real basic raffles right now, okay? So let's say that a TV is being raffled off, okay? There are 1,000 tickets that are sold at $2 each for a TV that's valued at $350. We want to know what's the expected gain for a person who purchases one ticket. So one of the first things you need to do every time, this might be a good note to make on your paper, is you have to figure out whose eyes this is going through, okay? This is saying what's the expected gain for a person. So this means it's from the viewpoint of the person buying the ticket, all right? Now, think about this scenario. We have two categories here. What are our two categories? You can either win the TV or you don't and you lose, right? You buy a ticket, you win or you lose. That's it. Okay, if it's me, I'm gonna lose because I never win. Those kinds of things, but that's okay, right? Perhaps you might be the person who always wins. There's always somebody, right, who's just got super luck. Now, if you lose, what happens to your net worth, your wallet, your bank account, right? If you bought a ticket for $2 and you lose, that means you're out $2, so you're negative money. If you win the TV, you're gaining a $350 television, but you paid $2 to get that. So really, what's your gain in that problem, right? If you paid $2 and you gain $350, you're really only gaining $348, right? Because you paid $2 out, right? So first, you figure out your money. I think it's easier to figure out your lose and then move over to your win. Right? I also find that students who take the time to write down win and lose tend to be more successful just because they've organized their thoughts on paper. All right? Now, what's the probability of winning? You buy one ticket and there are 1,000 tickets sold, which means what's your probability of losing? 999 out of 1,000. Checks and balances, your probabilities always need to add up to 1, right? Okay. Once you get here, when it's saying what is the expected gain, we're going to write the E of X, but that's really the same as finding the average that we've been practicing. To find your average, you take your X and multiply it with its probability plus the next X and multiply it with its probability. Now, of course, you don't have to write plus -2. You could just write -2, but remember it's plus the -2 that your value is, okay? It's not a subtraction problem typically. You throw this in your calculator and you're gonna get negative $1.65, which means what? All right, if you buy this raffle, let's say that a club, you're not allowed to raffle in school, but let's say they raffled in school a TV every week as a fundraiser. Okay, if they did that, if you bought that ticket every single week of your whole high school career, you're going to lose a lot, right? But you might win one of those. So over time, on average, okay, each time you buy one ticket, you will lose, on average, $1.65. Right? Over time, you can expect to lose $1.65 every time you buy a ticket, something along those lines. So part of it is find your answer, and then part of it is going to be also interpret what does that answer mean. All right, so example 8. Now we have 500 tickets being sold at $1 each for 4 prizes of $100, $50, $25, and $10. This is a key since we have multiple prizes, okay? I said after each prize drawing, the winning ticket is then returned to the pool of tickets. That makes it where it stays easy for us to be able to calculate our probabilities, because otherwise it's going to get really, really overcomplicated really, really fast, which means theoretically that one person could win all 4 prizes, okay? We want to say what is the expected value for a person who purchases 2 tickets. Right. Now, I put up high the 150, 25, 10, lose. Last time I just wrote win, lose, but you can win 100, win 50, win. There's 4 different ways to win. Now, I always start, just like last time, I always start with how much you lose. If you lose, what's going to happen to your wallet? You bought 2 tickets at $1 each, so you're out $2. Just a coincidence that they're both -2. Next example, it won't be that. All right. If you win the $10 prize, what happens to your profit? You really only gain 8 because you paid 2 to win 10. Okay. Your $25 prize will really only be a gain of 23. $50 prize is a gain of 48. $100 prize is a gain of 98. Okay. Now let's talk about probabilities. If 500 tickets were sold and you bought 2 of them, then what's your probability of winning this prize? 2 out of 500. The winning ticket is put back, so you have the same probability of winning this prize, 2 out of 500. You have the same probability here, 2 out of 500. Same probability here, 2 out of 500. Which means, what's your probability of losing? Be careful, it's not 498 because you've had 2, 4, 6, 8 chances to win already. So since you've had 8 chances to win, 500 minus 8 would leave you with 492 out of 500 chances to lose, because the ticket got put back each time we pick the next ticket, next prize. Setting this up is half the battle. Right? It's a lot of the battle, making sure that you set it up properly. Then you're going to do your expectation, your average. So your expected value, we're going to have 98 times 2 out of 500 plus 48 times 2 out of 500 plus 23 times 2 out of 500 plus 8 times 2 out of 500 and then minus 2 times 492 out of 500. Sorry, I ran out of space. Okay, put all that in your calculator in one step, right? And we're going to get an expected value of negative $1.26. So check to make sure that you are getting the same answer as me. If you're not, you need to let me know so we can fix it in class and I can help you out. So what does this mean? How would we interpret it? Okay, over time, every time you buy 2 tickets, you would expect to lose $1.26, right? Because it's important to remember raffles are always designed for the person to be losing money, the player, right? Boardwalk games, carnivals, all that stuff. It's all about the company making a profit and you losing money, the player, right? That's the point of the game. It's a business. So they have to figure out the values of their prizes to make sure that they're still going to turn a profit off of you. Vice versa, they would get a profit of $1.26 every time you buy 2 tickets, right? Because they're taking your money each time. Okay, so read this next example, number 9. Try setting it up on your own. Like try this guy on your own. And now I'm going to work through it with you. But give it a shot as you're, pause it, set it up. All right. If you've got a landscape contractor bids on jobs where you can make a $3,000 profit per job, and we've got the probability of getting 1, 2, 3, or 4 jobs per month are shown. We want to find the contractor's expected profit per month. So there's a 20% chance you're going to get 1 job, a 30% chance of 2 jobs, 40% chance of 3 jobs, 10% chance of 4 jobs. So we need to find the average number of jobs, right? So our average number of jobs, it doesn't matter if you put mu equals or E of x equals. It's 1 times 0.2 plus 2 times 0.3, 3 times 0.4, and 4 times 0.1. And that will give us an average of 2.4. But be careful. What does this represent? This is not our answer. This is jobs per month, right? But the question is asking us, what's the expected profit per month? So profit is $3,000 per job. So we're going to multiply that with the $3,000 per job, and that will give us an expected profit of $7,200 per month. Now, this is a quite simple example, but this is a big component of how businesses can apply probability into their business models, right? Based on past experience, based on other ways that happen, other businesses, what they can make estimations. It's going to be more complicated than this. This is like stats 101 level, but, and there's lots of complicated statistics that can go into business analysis. Tons. Awesome, super fascinating stuff. But this is a basic way that they can approach it, right? The other way that this can be applied that isn't raffles is with life insurance. Now, technically it can be applied with any insurance. Car insurance, health insurance, home insurance, but they're all, again, another example that's too complicated for us to think about. All right, so one of the basic things I want to just clarify with you guys is to make sure you understand that insurance, when you pay insurance, the insurance company charges you a rate based on the probability that they're going to have to pay out based on a claim. So car insurance, teens pay more than middle-aged adults typically, because statistically speaking, the probability of a teenager getting in a car accident or a fender bender or something is higher than the probability of a middle-aged adult. So they're going to charge more because there's a greater chance that they're going to have to pay to replace your car or someone else's car or something like that. With car insurance, there's too many categories. Right? If you think about the idea of setting up these, there's so many fender bender, both cars fender bender, or people injured, like there's all those scenarios, all right? The other big thing that you need to think about is when you pay for your insurance for the year or the 6 months or whatever your policy is, if you don't make a claim, you don't get any money back. So if your car insurance costs $800 a year, you pay out $800. If you have a perfect driving record that year, then they keep your $800 and you don't get to get anything back. They use that $800 in a big pool of money to pay for other people's car accidents and replacing other cars and stuff. All right. So that idea of insurance is used everywhere. Okay, like that idea of keep your money, put it in a big pool of money to pay for other stuff. That's the whole concept, very basic concept behind insurance. We can talk about life insurance, right? Because life insurance, category-wise, really is just when you have your money and your probability. Life insurance is just about living and not. Okay, so when you have a life insurance policy, you buy a policy, You pay for it each year, okay? And if you live that year, the insurance company keeps your money and then you pay again next year. But if you were to pass away and you paid your life insurance that year, then your family will collect your life insurance payment in the amount that you had purchased. So for this problem that I've created, okay, if a person purchases a $50,000 one-year life insurance policy at a cost of $500, that's going to be called your annual premium. That means that the person pays $500 a year, and if they were to pass away, then their family will collect a $50,000 check, okay? And life insurance companies have tables of probabilities based on your age, your gender, smoker or not, family history. They collect all that information when you buy your insurance policy to calculate probabilities for living and not that year. So when you think about it, if I buy this policy this year, okay, I pay out $500. If I live, that means my wallet, my bank account is negative $500. If I pass away, my family will get a check for $50,000, but I already paid out $500, which means that the gain for my estate would be silly Mrs. McMichael, $49,500, not $45. Okay, $50,000 minus the $500. The probability of living. And then these need to add up to 1. So 1 minus this would leave me with 0.0037. Okay. When we work on this, to find the expected value, this is the expectation for the purchaser, the person purchasing this policy. My expected value, I'm still going to approach the same way as I approach the averages. It's going to be this X times its probability plus this X times its probability. Put this in your calculator, check to make sure you're okay with it. We would get negative 315, which means, write down your interpretation. How would we interpret this? Each year you buy this policy, you're going to lose on average $315. Okay, if you buy this policy starting at age 30 and you buy it for the rest of your life, right, you're going to keep paying out. So on average, you're going to expect to lose $315. Okay. Or every person that purchases this policy, on average, they're going to lose $315. The majority of people, probability-wise, will live that year. So they're going to lose their money. They're going to lose their $500. But there is a probability of people passing away, so then their families will collect that. Now, what if I change the problem and I just say, same scenario, but I want you to find the expectation for the life insurance company. So our table is the same, money, probability. We have live and die. Okay, the probability of living is still the same. The probability of dying is still the same. But what happens? For the company, everyone who lives, the company takes their money, which means it's a $500 profit for them. Okay, and then everyone who passes away, the company mails out a $50,000 payment, which means they're mailing out $49,500. Okay, yes, they're mailing out $50,000, but the company kept their $500. So this is the loss for the company. When you do your expected value, it winds up that it's positive 315, which means that everyone who buys this policy, this $500 policy, the company makes $315 profit on average on each one of them. Okay, of course, we're going to talk more about these later. Okay, we'll practice. Here are some really good practice problems to work on. I'll officially assign them at some point in Google Classroom, but if you want to tackle some of these on your own, it's a great idea. Okay, good job today.